Hello everyone. Today we will do electric field intensity due to infinitely charged sheet. This is by Root Academy. So this is a very easy derivation and mostly it is asked in exam. So this is a positively charged sheet. We are showing it a finite size in the diagram, but assume it is an infinitely large sheet with positive charge. Correct? So what is the rule of flux? For a positive charge, flux lines are going outward. That is how it happens. And for negative charge, field lines, which are also called flux, they go inward. This is a rule, correct? For positive charge, flux going out, for negative coming in. So if I want to plot the flux for this sheet, this for this sheet, the flux will be either upward or downward, going away, because flux is always perpendicular to the surface. So it will be either upward or downward. It will not be left or right. To calculate electric field, we will use Gauss's law. Okay. For that, what do we know? First of all, we will calculate flux by first principle. Write down by first principle or by the definition of flux. The definition of flux is nothing but E into ds integration, or we take sigma of E del S. Both are correct. Okay, so whenever we take ds in definition, we use integration. Always remember. If we take del S, then we use sigma. Okay, so flux is nothing but the product of E, electric field intensity, and the surface area over which flux is measured. So for this, let's apply Gaussian surface. So Gaussian surface, again we will take cylindrical of area A, which will cover the area A of the sheet. You know, area A is covered on the sheet. Top and bottom area is A. Okay. So we know that the flux from top surface is suppose phi 1, from the side surface is phi 2, and at the bottom surface is phi 3, suppose. So what is phi 1? From basic definition, E into sigma of del S. Sigma means entire area. Sigma means entire area over which we are calculating flux. So this area. Okay. So let me assume this area is A. So this is phi 1. What is phi 2? The flux over curved surface area. So all around it. So all around it, if you observe, there is no flux. Correct? So its value will be 0. And what is phi 3? Phi 3 is the flux over the down surface. So it will be exactly same as the top one, which is E into A. Correct? This and this, which is E into. Understood? So what is the phi net? Total flux will be phi 1, correct, plus phi 2 plus phi 3. Yes. So phi 2 is 0. This is 0. But phi 1 is EA plus 0 plus EA is nothing but 2EA. Always remember, E is a different thing. Epsilon is a different thing. Okay, E is the electric field. So this is the phi net. By using Gaussian surface separately. Now, this is by using the basic formula. I'm sorry, by using the basic formula. Now we will apply Gauss's law over this entire surface. So if I apply Gauss's law over the entire surface, what it says? That net flux is nothing but charge enclosed by epsilon. This was given by Gauss's law, and this we got from basic definition. Let me call this as equation 1. Okay, this one. So net flux by definition is this, and net flux by Gauss's law is this. So by basic principle, these two should be same. Theoretical should be equal to practical value. तो आपका phi net is equal to 1 is equal to 2. Correct? I can write Q by epsilon naught is equal to 2EA. Perfect. So from here, what conclusion we can draw? Can I say that E is nothing but E is this, is nothing but Q by 2 epsilon naught A. Perfect. And what is Q by A? Anyone? What is Q by A? It is nothing but charge per unit area. Sigma, the charge density. Q by area. This is nothing but charge density per unit area. So Q by A is nothing but sigma. So can I say sigma by 2 epsilon? Okay, so this is what we got. So that means E is nothing but sigma by 2 epsilon naught. This is due to a single sheet. Okay. What is sigma? Sigma is a Q by area, charge per unit area. And what is epsilon naught? It is the permittivity of medium, whatever medium you are working. Here it is air. Points to be noted. Like here, point to be noted is E does not depend on distance. Means whether you are very close to plate or you are very far from plate, the electric field intensity will remain same. It does not depend on the distance from the straight wire. Okay. So if you have to draw E versus R, so E value will be almost constant. It will not vary with going away from the plate. Okay. See you in next video. Bye everyone.